Okay, so hello, my name is Vladimir Losev. I'm a head of crowdsourcing tools development group at Toloka, which is a crowdsourcing platform. And some time ago, we released a Python library for interacting with our platform with Python. While developing this library, we encountered several problems with IDE support. And today, I would like to share our experience and tell a bit about how we dealt with poor code analysis support in our generator meta class and code generation heavy projects in IDEs. So let's start with some demonstration. What am I talking about? So for the purpose of this talk, all the screenshots are from PyCharm that I'm using, but technically it is quite similar in other IDEs as well. So say we would like to create a module that is called sleepy. In this module, we would like to introduce a function that is called sleep4. The difference between the time sleep, that is a function in standard library, and the function we are going to write is that sleep4 would accept additional argument that is called unit. And we can say to our function sleep for half a day, 5 hours, 3 seconds, or something like that. So this is the implementation of this function. If we try to use our sleep4 function somewhere in our code, we would see that IDE would show us the signature. If we start typing the name of an argument, it would highlight the name of the argument. And if for some reason we try to pass an argument that is not in the signature of our sleep4 function, IDE would highlight these arguments and say that something is wrong with this. But let's write a simple decorator. So let's write a decorator that is called log function call. So it would write in the log a message every time we are calling the function and every time the function is completed. So one would write the log function call something like this. And if we initialize properly our logging and run the function, we can see that every time we run our sleep4 function, we actually do write some messages in our log. So this works. But let's have a look at what happened to our IDE hints. So now after we applied the logging decorator, we can see that we no longer can see the signature. We no longer have access to the hints of argument names. And if we pass an unexpected argument, we no longer see it highlighted. Everything is gone. What might be the cause of this? So technically, log function call decorator, as almost every decorator, substitutes one function with another. And in our case, we substituted the sleep4 function with a wrapper function. And the wrapper function accepts all kinds of arguments. So it accepts star args and double star quarks. And maybe that's the reason that the signature is broken. But no, it's actually not the case. If we import the inspect module and from inspect module, we use a signature function that returns a signature for the function and apply the signature function to the decorated sleep4 function, we can see that all the information about the signature is still there. The IDE just doesn't pick it. So what actually went wrong? Well, the reason for IDE not to help us with hints anymore is that IDE actually uses static code analysis. So all this information is available at runtime, but IDE only resorts to static code analysis. And there are plenty of reasons to do so. So the three that I came up with is possible side effects. So IDE is afraid to run our code because our code might have some side effects. It may raise exceptions or run for an infinite amount of time, or even at some points when we are writing code and we are typing the name of variable, the code might not be syntactically correct if we are in the midst of writing our code. So runtime might not, runtime inspection is not an option for IDEs, and they resort to static code analysis. And this is a pretty difficult job. So what can we do with this kind of problems? Well, generally, it's a good idea to provide as much information for the static analysis tools as we can. And for this particular case, we could resort to adding some type-var hints to our log function call decorator. So here we are telling that log function call decorator actually returns the same thing in terms of types as it accepts. And if we update our code like this, we can see that we, for some reason, still do not have signature highlighted. But if we start typing the name of an argument, we can see that we have this kind of support, and there is a small window that actually shows the full signature of the function. So technically, IDE has access to this information. It just for some reason does not show everything that it could. Maybe it's due to the bug in my particular version of an IDE, but technically the information is there and IDE could pick it. And for some reason, unexpected arc is not highlighted as well. But this was actually a simple case, and there are cases where we cannot resort to adding additional information. And let's have a look at a more advanced decorator. So let's say our module is in PyPI. It has some amount of users, and users came back to us with a feedback that they do not want to import time unit from our Sleepy module and pass it as an enum value. For some reason, they want to be able to use a string value as well. So technically, we want to support both types of calling the function, providing a unit as an enum value and providing a unit as a string value. So what we do, we write another decorator that we call autoenum. The idea behind the autoenum decorator is that it accepts a function, it inspects the function, and returns another one. And for the decorated function, it actually tries to convert values to the enum values in the signature. So let's have a look at how one could implement such decorator. So it's quite a lot of code, so let's go through this. First of all, we retrieve the original signature of the wrapped function. Next, we define a wrapper function, and inside the wrapper function, we bind the arbitrary arcs and quarks arguments to the original signature. Next, we traverse the bound arguments. By bounding arguments, we can now know which argument was passed to which argument. And if the argument we are currently looking at was annotated as an enum value, and for some reason, the actual value that is passed to this argument is not an enum value, we try to modify the arguments. We try to cast them to enum that was in the annotation. Next, we have a block of code that preserves the actual signature. So after applying the decorator, we now no longer accept only enum values as an argument for some of our arguments, but we can accept both original enum and a literal value, a string value. And next, we update the wrapper function we assign to a under signature method the updated signature. And that's how the inspect and all other possible utilities would know the signature, the updated signature of the wrap function. What happens in IDE if we apply this kind of decorator to our sleep4 function? We can see that IDE thinks that minute argument, that is a string, is not a valid argument, but that actually works. So how can we fix the problem? Because for this type of decorator that is fairly complicated, we cannot come up with some simple additional typing annotations that would help our static analysis tools. So the reason that we came up with is, by the way, this slide just shows that the signature is there and valid. So the solution we came up with is stub files. So stub files is a part of language standard. It was introduced in PEP 484, and it is a separate file. A stub file is a separate file that contains only type hinting information. And it was introduced for the following purposes. So when the Python 3 was introduced and type hinting were a new features, developers wanted to support type hinting in their Python 2 and 3 compatible modules, but annotations were not syntactically correct thing in Python 2. So you could not just use an annotation in Python 2 and 3 compatible module. That's why the type hinting information, the solution for this problem was to create a separate stub file where to put all the type hinting information. There are actually several more reasons for using stub files, the motivation for these files. So if you're writing an extension module, like writing the implementation in C language, or if you want to have a benefit of type hinting in a module where authors did not yet add type hinting, or the module, if you are using annotations for some other purpose in your code than just type hinting, you could add the type hinting information in a separate stub file and use this. So long story short, if an IDE finds a corresponding stub file for a module, it will analyze the stub file instead of the original file for syntax highlighting. So what should we put to our stub file? So generally, you should put public member definitions, annotations, docstrings, function signatures after resolving the decorators, constants where it's possible, and all the necessary imports for this stub file to be a valid Python file. What can be omitted? You can omit private members, the decorators, and function implementations. So in our case, if we want our sleep4 function to have a stub file, we would put the following code in our stub file. So we would define a sleep4 function. We would define it with the desired signature. We would not have the implementation. We would just put a pass or 3 dots there. Because we want this file to be a syntactically correct Python file, and in annotation we used the time unit, we would have to put a definition of time unit in our stub file. And because in our annotation we are using union, literal, and stuff like this, we should import this as well. So this would be the desired content of our stub file for our init.py module. And in PEP 561, there was introduced a new rule that every package maintainer who wishes to support type checking of their code through the stub files must add a specific marker file to their package that's called PyTyped, and we would do just this. We would create an empty file that is called PyTyped. Now let's have a look what effect this took on our code. So after adding a PyTyped and a stub file, by the way, the convention is that the stub file for a module should be called absolutely the same, but the extension must be PYI instead of PY. So after adding a stub file and a PyTyped file, we can see that our IDE highlights the signature. It shows us the autocomplete of an argument name. If we put an argument that shouldn't be there, it highlights this argument. And if we are using string instead of the enum value for our particular case, it does not show us an error anymore. And actually, if we run the code, everything works. So it might seem that we are victorious, but there's a problem, because all the decorators are there in order to eliminate the boilerplate. But now, in order for our IDE to have the full support of our code, we have to maintain additional stub files close to our actual code. Actually, we created more boilerplate for ourselves. So the solution we came up with is an automatic stub generation. So the general idea here is that IDE is afraid to run our code because it is afraid of side effects or possible problems it may encounter, and thus cannot have introspect the runtime objects. But if we are sure that our code is good enough, that importing a module does not produce any side effects, errors, or does not run infinitely, we can import our module, introspect it ourselves, and then from this introspection, we can create a stub files ourselves. And this stub file would be easy to pick for our IDE. So let's have a look at the code just to get ourselves familiar with the principles. So if you wanted to implement this approach, you would write the code that would look something like this. This is a simplified version that only works for functions, and it has some issues, but let's go through this code. So first of all, we have a function that takes two arguments, the name of a module and a path. What it does is it takes a file by this path and tries to import this as a module object, and this module object would be named name, whatever name you pass to the name argument. We would also have a generate stub content function that accepts a runtime module object, and it would go through all the attributes in this module object. And for the purpose of this example, if the value is a function and this function was defined in this module, because the functions might be imported, but we only want to put definitions for the function that are defined in our module. We would write the simple stub. So we would write a simple definition for the function. We would write the def, name of the function, the signature that is provided by a signature object, and an empty body. And we have a main function that brings two functions together. So it takes a file by the path, creates a runtime module objects, and generates a stub content from the runtime module objects and writes this to a stub file. If we run this code on our Sleepy module, we would see the following results. So this is quite a lengthy string. If we format refactor this string, it would look something like this. So we introspected the module and we created our sleep for function. As we can see, there are several problems here. First of all, is that signature object is not quite produces not quite syntactically correct definition. The problem with time unit as a default argument. And we can see the problem that we are using union, we are using time unit and literal, and we did not import or define this classes or whatever in our stub file. We should have done this. But the idea is like this, and technically it can be done. And we did it for our project. And the tool is called StubMaker, and it is open sourced. I will have a QR code later in my slides. So we have a limitation for our tool that it only works with modules that have dunder_all attribute in it. It was just easier to implement the tool if that was a prerequisite. So let's add the dunder_all attribute to all our modules and run the function. So and run the tool. So let's have a look at what the tool generated. For our init stub file, we generated a stub file that looks like this. As you can see, it created a docstring for our time unit. That's because every time you inherit from a time unit, from a enum value, it actually automatically adds a docstring for your type. And you might not even notice this. The stub files that were created for other modules are quite simple. Nothing interesting here, but this works. And the bonus, everything that I was telling about was not only specific for the IDE support, but this actually might help with other static analysis tools as well. So I do not have a specific example here, but if you run the first example with the simple decorator, you might see that MyPy would not pick an incorrect argument. But if you created a stub file for the module, MyPy would pick the stub file and identify that the argument, unexpected argument you pass is not in alignment with the signature of your function. So I guess that's it. You can find the project by the QR code at the top. You can also contact me sometime later in our Slack community by the QR code later. And just in case, if you would like to get yourself familiar with the crowdsourcing tools that Toloka provides, you can go to this QR code, and we actually have some promo code as well. So that's it. Thank you for your attention, and I would be glad to answer the questions.